So here we're going to look at one of the most, I think, confusing elements or aspects of exponentiation or exponents. That is to compare a positive and negative exponent. And here's the confusion and the question I have from one of my students, which is that, okay, so if 4 squared equals 4 times 4, and that's 16, how come 4 to the negative 2 equals 1 over 16? In other words, the question is, shouldn't 4 to the negative 2 equal 4 divided by 4, which is 1. You see, the connection is that, and this is not true by the way, we'll talk about why, but the connection and the question is, well, if 4 squared equals 4 times 4, why isn't 4 to the negative 2 equal 4 divided by 4? What's going on here? Well, there's a couple of ways to look at this about why this is not true, even though we feel that shouldn't it be? Like question mark, shouldn't this work? Here's the first aspect. The first is to use a pattern. So if we have 4 squared, I think to myself, that's 16. And 4 to the first, that's 4. And 4 to the 0, well, here's where we start to follow our pattern. Every time our exponent decreases by 1, we have 1 less 4. In other words, right, we divide by 4 each time, and here we get 1. We follow that pattern of division. So the idea is that if we keep following that pattern, we know that 4 to the negative 1 should be 1/4, because every time we move down the pattern, we're dividing by 4 again and again and again. So here with 4 to the negative 2, we should get 1/16, right? We're dividing a fourth and 4. And that's a nice useful pattern, I guess. That's one way to look at it. You can also build off this pattern and say, oh, I noticed that 4 squared is 16, and 4 to the negative 2 is the reciprocal of that, right? It's 1 over 16. That's true for each of these. 4 to the first is 4, and 4 to the negative first is 1 over 4. 4 to the 0 is its own reciprocal, but we have these other nice connections to build off of. And that's pretty much how I deal with exponents. I think, okay, if 4 to the negative 3 is what I have to solve, I think, what is 4 to the third power? Well, that's 64, right? So 4 to the negative third is 1 over 64, or you can think of it as 1 over 4 to the third. And this brings to light our general definition of negative exponents. X to the negative n power equals 1 over x to the positive n. You see it right here. 4 to the negative third equals 1 over 4 to the positive third. This is a basic definition. But that's just one way of looking at it, the pattern that justifies the answer. But let's go back to the original misconception here. Right? If 4 squared equals 4 times 4, why doesn't 4 to the negative 2 equal 4 divided by 4? Well, I think we have to think about what's really happening here with 4 squared and go back to the crucial, I think, turning point of the exponential process, which is the 0 power. Here's the idea, right? If 4 to the 0 is your basis for all the other ones, and that just equals 1, that tells us something. That tells us that when you're dealing with exponents, right, and 0, of course, is always your starting point, it tells you that 1 is really the starting point of the process. So 1 is the starting point of your exponential pattern, right? This is crucial because what this means is if 4 to the 0 equals 1 and we build up from there, 4 to the 1 doesn't really just equal 4. It equals 1 times 4. We're building off of 4 to the 0. And 4 squared equals, again, building off of 1 times 4 times 4. So now let's go back to our original assumption. We think that 4 squared equals 4 times 4. It does, essentially, but really, right, the true exponential expression we can represent as 1 times 4 times 4. It's still 16, but it enables us now to think about this one a little bit more clearly. Because let's go back to our pattern. Well, here, this again is equal to 16, and then 4, and then this is equal to 1, of course. But 4 to the negative 1, we said, is 1/4. Well, that's because we start again at 1, but now we have a negative exponent, which means division. So starting at 1, we then divide by 4 once, right? That equals 1/4. So 4 to the negative 2, what it really equals is 1 divided by 4 divided by 4. So you're dividing 1 by 4 twice, and that's 1 over 4 squared, which is 1 over 16. So don't worry that the two 4s are still there as we think that this 2 represents, which is true. but the negative means we're dividing. However, to really understand what's happening, we need to think about the fact that we're always starting with 1. That's our starting value. So you can imagine that 4 to the negative 3, or anything to the negative 3, can be thought of as 1 divided by this base value, right, this many times. 3 times the absolute value of negative 3 times, which is just 3. Right, divided by 4, divided by 4, which is essentially 1 over 64. So again, x to the negative n equals 1 divided by x, right, divided by, and so forth, this x, n times. If you want to think about it that way, that might really help you deal with this confusion right here. So 4 to the square does equal 1 times 4 times 4. So 4 to the negative 2 doesn't equal 4 divided by 4. It equals, right, to rewrite this, 1 divided by 4 divided by 4, which is 1/16. All right, so I hope this helped.